Hello, hi everyone. Welcome to the student brand new channel. Today we are going to discuss about important topic, that is electricity. So what is that? What topic we are discussing? Electricity topic. Okay. So in this topic we are going to discuss. First one is we can consider what are the topics we are going to discuss. So I'll explain. First one we will discuss electric current, and second one potential difference, and third one we can see electrical components. What are the electrical components are there? Electrical components. And fourth one is Ohm's law. And fifth one, if you consider, factor depends on resistance. Factors depends on resistance, and we'll talk about sixth one, resistivity. We'll talk about resistivity. And the seventh one, if you consider, heating effect of electric current. And their applications also will discuss. And eighth one you can consider electrical power. Clear? So these are the topics we are going to discuss today class. So note down all the points. So if you have any doubts, you can ask, you can comment below. So I'll clarify your doubts. Just check once. Meanwhile, I will go with the topics. First one is, once again repeating the topics, electric current. Second one, potential difference. Third one, electrical components. And fourth one, Ohm's law. And fifth one you can consider factors. Factor depends on resistance. And sixth one is resistivity. And seventh one, heating effect of electric current. And eighth one is electrical power. Clear? So these topics will be discussing today class. So I hope you note down, completed. Yes. Now we can see from starting onwards we will discuss all the points whatever it is there. So we'll go with the starting topics. What is the first topic? Electric current. So I will briefly discuss about topics. So carefully note down. So if it is possible, you can, if you have any doubts, you can ask. First one is electric current. Electric current is nothing but, okay, so the rate of flow of charge, I equal to Q by T. So rate of flow of charge. So this also we can consider the flow of charge through unit cross sectional area per second. The flow of charge through unit cross sectional area per second, that is nothing but electric current. Clear? So I equal to Q by T. We are considering. So what is I? I is current. So it is very helpful for 10th standard. Those are writing a board exam. So make sure that you are noting down all the points. So this I is the electric current. Okay. So this is a current. I is nothing but current we can consider. And what is the Q? If you know, so you can comment below. So what is the Q? Q is the charge. Q is the charge. And what is the T? Time. What is the T? Time. So I is the electric current, Q is the charge, and T is the time. Okay. So in exam there will be asking, so SI unit of current. What is the SI unit of current? Ampere. So on ampere we can consider. So we can also write. So we have to write small letters. And honoring the scientist, we are writing small letters. So we have to write 1 ampere like this. We have to write. If you are writing complete word, if you are writing complete word, you should write small letter. So all small letters you have to write. So if you are writing symbol, you can write 1 ampere. And charge, if you consider, so this current I we can take. So charge, if you consider coulomb. Okay. So coulomb denote with the letter C. And next one, time, if you consider second. SI unit of time is second. So anyway we can consider all these points. So this about electric current. And next one, if you take I equal to Q by T, so you consider, right? So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So it's very, very important. So keep in mind, because 1 ampere, so in the exam they ask 1 ampere of current is equal to 1 coulomb of charge passing through unit cross sectional area per second. So 1 ampere of current is defined as 1 coulomb of charge. 1 coulomb of charge passing through unit cross sectional area per second. That is nothing but electric current. Electric current. So I equal to, so 1 C by 1 second. So this is about electric current. And one more thing, so here normally if you consider charge in the conductor, so electrons will not move a single, like a one electron, 2 electrons will not move. So number of electrons will move. Number of electrons will move. So that's the reason we are taking the charge. Q is, so plus or minus Ne, plus or minus charge, the rate of flow of charge. So positive charges and negative charges also moving. So that's why we are taking only electrons. The rate of flow of electrons will be considered electric current. The direction of electrons only will be considered as a electric current. So so charge is nothing but both positive charges and negative charges will come. So that's why we are taking plus or minus. So we can take Q equal to Ne. Okay. So N is the number of electrons present in the particular conductor where we are taking the current flowing. Okay. That's enough. So this is about then what will become the formula? I equal to Ne by T. I equal to Ne by T. So I equal to Q by T, right? Instead of Q, so we are substituting Q by T, right? Instead of Q, we are substituting Ne. So yes. So I hope it's not visible. Okay, done. So you can substitute instead of, so here you can consider instead of Q, you can substitute this value, you will get it. That is nothing but I equal to Ne by T. Ne by T. So clear? So this is about electric current. I hope it is clear. So if you have any doubts, you can comment. So in comment section below. So I will clarify your doubts. Right. Then next one. So based on this one, problems also will come. So we'll do one problem. Okay. So we'll do one problem based on this one. So what is the problem? Yes, it's very, very important. The charge possessed by an electron is 1.6. So I'll be rubbing. So try to do the problem. So I'll write this problem. Okay. So the class will take more time. So if you are listening, so make sure that you are noting down all the points. So here you can consider the charge. Question is the charge possessed. So here yes, the charge possessed, the charge possessed. So here you can take is possessed by an electron, by an electron that is electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. Current of 1 ampere. Yes, so this is the question. So now if it is clear, so just check once. Here one electron, this is electron, okay, charge possess 1.6 into 10 power minus 19 coulomb, 1.6 into 10 power minus 19 coulomb. Okay, so here you can consider, once again I am reading the question. So one charge, the charge possessed by an electron is 1 point. So you can consider 1.6 into 10 power minus 19 coulomb. Okay, so electron charge, and find the number of electrons. We need to find number of electrons, and we have to find out. So that will flow per second to constitute a current of 1 ampere. So 1 ampere. So by this, what the given data? So given data, if you consider, that is, one is electron charge given, that is 1.6 into 10 power minus 19 coulomb, okay, and current given, how much? 1 ampere given. Okay, now we know what is the formula. We know the formula, I equal to Q by T. So Q equal to NE, we know NE. Then if you substitute I equal to NE by T, so right? Yes. So now we need to find out N value. And per second also, sorry. So per second, that is nothing but time given per second. Yes or no? Here per second given, So then time also given. Then we can find out, substitute all the values and do it. Just try the question. If you know the answer, just let me know in the comment section below. Okay, so we'll do it once again. So this is the given data. Now we can consider, so I'll do it, I equal to Q by T, that is nothing but I equal to NE by T, right? Yes. Now you can consider N equal to I into T by E. So if you substitute 1 into 1, 1.6 into 10 power minus 19. Why you substituted here? Electron given, right? So one electron equal to how much charge? 1.6 into 10 power minus 19 coulomb. So we got it, this one, right? That's why we are taking this one. So if you do this calculation, so you'll get N equal to 1 by 1.6 into 10 power minus 19. Then you will get 1 by 1.6, it will goes up 10 power 19. Okay. So normally if you are considering, so here 1 by x, so if you write x power minus here, 1 by x power minus 1, 1 by x square, so x power minus 2 will be writing, right? Same thing here also. If you take 1 by 10 power minus 19, if it is goes up, 10 power 19 will come. Then if you solve this one, so 1 by 1.6 into 10 by 10 we can multiply, then they will get, so what you will get? So here 10 by 16 you will get into 10 power 19, plus 19, right? This is plus 19, yes. So if you do this one, okay, if you solve this one entire thing, so you'll get overallly 6.25 into 10 power 18 electrons. So try to do it, you'll get it, the answer. So this if you solve, automatically you'll get this answer. Clear? So that is about electric current. So formula and definitions based on like this problems also they will ask. Okay, next we'll go with the potential difference. So we'll go with the potential difference. There are many points are there related to potential difference. So just note down these points. We'll go with the potential difference. Clear? Yes. So now I'm rubbing this point. So potential difference. What is generally potential difference? So anyone knows? So if you know, just you can let me know. Okay, potential difference. Potential difference. Clear? Yes. Potential difference is nothing but normally if you take two beakers, I'm taking two beakers. So this is one beaker, another beaker like this I'm taking. Okay, beaker 1. So I'm taking beaker 1 and beaker 2. Okay, so I fill the water until the top. So until the top I fill the water. So here like this. And here also I fill the water like this until the top. I'm considering like this. Okay, yes. So then what happens if I connect here? If I connect like this, so water will flow? Water will flow? No, there won't be any flow. Because why? Here already, so here also same level, here also same level. There is no difference. Then beaker 1 to beaker 2 or beaker 2 to beaker 1, there won't be any flow. So there won't be any flow. But if you create some difference, I'm creating some difference. So stand I'm taking, certain height I placed. Okay, so here also one more beaker I'm taking here, right? Yes, so support I'm considering this support. Then if you consider, so water is filled until the top. So this is a beaker 1 and this is a beaker 2. So beaker 2 I'm considering. So now I'm connecting like this. Okay, so connected, can consider. Yes, so like this I connected. Then you can understand, so water flow will be there, beaker 1 to beaker 2, beaker 1 to beaker 2, water flow is there. Why? Because some difference is there. There is some difference. Okay, so yes, if it is not visible then check once. So I understood, right, this one, and the next one I will draw. So here you can see this one and one more height I placed. Okay, like this, and here also like this. Yes, so water is there here and here also water is there. Now, so here you can consider, so some I am considering like this. So now you can take beaker 1 to beaker 2, water will flow because some difference is there, some height difference is there, that is the reason water is flowing. But where are you take a straight conductor, I am taking the straight conductor, okay, copper wire, so I am taking like this. So will the electrons will move? Will the electrons will flow within the conductor? No. Why? Because there is no difference, there is no pressure difference, electrical pressure difference, there is no electrical pressure difference. That is the reason electrons will not move within the conductor. So like this, even the electrons are there, but still electrons are not moving because there is no difference. So normally if you take the temperature will move from higher region to lower region, higher temperature region to lower temperature region, the temperature will travel, the temperature will move. But here electrons will not move because there is no difference, there is no pressure difference, electrical pressure difference. Okay, so for that what we are doing, when we connect the battery, so normally if you connect, so I'm taking the wire here, wire I'm considering, so this is a battery. So if you take positive terminal, negative terminal, so current will flow. Why? Because battery creates the difference, battery creates the difference, the pressure difference, electrical pressure difference. Okay, so how the temperature will move, the same thing, so electrons will move. Okay, charge will move from one point to another point. There is a difference. When there is a difference, the electrons, the charge will move, Clear? Yes. So here also the same thing. So if the difference is there, automatically charge will move from one point to another point. So that is nothing but potential difference. So what is the potential difference? So V equal to W by Q. W by Q. So work potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. So I am taking this point A and this the point B. So charge, if you take this a charge, so the charge will move from one point to another point, okay. So when we do some work, when we connect the battery, it creates some difference. So work is done to move charge from one point to another point, okay. So potential difference is nothing but work done to bring unit positive charge from one point to another point. So okay, so potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. That is nothing but potential difference. Clear? Yes. Now we can take, so V equal to W by Q. We can consider. So what is SI unit of potential difference? SI unit of potential difference is volt, and SI unit of work is joule, and SI unit of charge is coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Once again, 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. So that is nothing but potential difference. So 1 volt equal to 1 joule per 1 coulomb. Clear? Yes. So that is a potential difference definition and SI unit of potential difference. So we discussed. Clear? Now we can consider one more point is the electrical potential. So you know potential difference we know. What is this electrical potential? Electrical potential is nothing but same like this, work done to bring unit positive charge from infinity to the required field. So that is nothing but electrical potential. What is electrical potential? Work done to bring unit positive charge from infinity to the required field. So here this charge is there, positive charge. So this is the field I am considering. This is a positive charge, this is the field. So we are doing some work to bring this positive charge at infinity from infinity to the required field. That is nothing but electrical potential. Clear? Yes. SI units, everything will be same. We can consider that is about electrical potential and potential difference. Hope you got clarity on it. Now we will discuss about electrical components. What are the electrical components are there? We will discuss in this class. So electrical components. What are the electrical components? Electrical components. Okay. So first one is, so what is this one? Switch. What is this one? Closed switch. Next one, open switch. Second one. And third one if you consider cell. This is cell. Positive terminal, negative terminal. Next one, fourth one is battery. If you take, this is a battery. I'm considering this is a battery. Positive terminal, negative terminal. Okay. Next one, fifth one is bulb. So bulb, if you take, this is a symbol for bulb. Okay. Sixth one, resistor. So this is a resistor. So what is a resistor? So we'll discuss about this resistor. Resistor is nothing but, okay, the device used to oppose the electric current in the circuit. So closed switch, open switch, cell, battery, So two or more cells will be combined. What is the difference between battery and cell? So cell means only single one. Battery means number of two or more cells will be combined together. That is called battery. And bulb already. So resistor is nothing but the device used to oppose the electric current. So here, so closed switch, okay, and this one is open switch, and this one is cell, and this one is battery, and this one is bulb and resistor. Clear? You got it? Yes. Now, so we'll discuss about briefly about resistor. What is a resistor? Resistor is a device. Resistor is a device which oppose the electric current. Resistor is a device which oppose the electric current in the circuit. It is a device. It is a device we use to oppose the electric current in the circuit. That is called resistor. Yes, clear? Resistor. Yes. Resistor is a device which oppose the electric current in the circuit. If you take this one, okay, resistance. What is the resistance? Resistance is the phenomena, the process in which the electric current is stopped. The electric current, the flow of electric current we are stopping, right? We are opposing, right? That is called resistance. So be very clear about it. Sometimes generally when we ask a resistor, what is the resistance? So people will get confused. Sometimes if they ask resistor, they'll be writing the resistance phenomena, and sometimes they'll ask resistance, they are telling about resistor. Okay, so be very clear about the topics. Be very clear. So resistor is the device. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing electric current. Clear? So that is about resistance and resistor. SI unit of resistance. What is the SI unit of resistance? SI unit is ohm. SI unit of resistance is ohm. We can consider. Clear? SI unit of resistance is ohm. Symbol if you take. So this is a symbol. Children, this is the symbol. So I am taking this as symbol. Understood? So you must understand these meanings. Okay. So very, very, very important these topics. Okay. So be clear and note down all the points. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Clear? And the next one, SI unit of resistance is ohm. SI unit of resistance is ohm. Symbol is this one. Symbol is this one. Okay. So clear about it. Next one more it is there. When it comes factor depends on resistance. I will discuss more points related to resistance. So meanwhile we'll go with the components. And next one, ammeter. Ammeter, if you take this ammeter, okay. So positive terminal, negative terminal. This is the ammeter. So we have to write like this, ammeter, according to, okay na? So we have to write this one, ammeter. First one is electric current. So I'll tell 4 points. Just note down electric current. Electric current. Second one, ampere. And third one, ammeter. And symbol capital A. Here you need to understand the meaning of all these 3 points. Actually this is the 4th point. Okay, so beside of second point only I wrote. So to understand. So electric current. What is the electric current? I equal to Q by T. So just now we discussed it, right? So starting topic, what is that? Rate of flow of charge through unit cross sectional area per second. That is I equal to Q by T. The rate of flow of charge through through unit cross sectional area per second, that is called electric current. I equal to Q by T. Clear? Yes. Yes, got it. But ampere is the SI unit of electric current. Ampere is the SI unit of electric current. The symbol, so symbol is capital E. Symbol is capital E. So while writing ammeter, so we have to write capital letter. Starting you have to write capital letter according to the English. Okay, so you can follow that capital letter starting. But so while you are writing units, you must write small letter. You must write small letter. Why? Because on honoring the scientist, so we are giving the SI unit of current is ampere. Okay. Yes, that's enough. So these are the 3 points you must remember related to electric current. So here ammeter is a device used to measure the electric current. So here it's very important. Remember this point. Later I will talk about it. So because it's very important. So while it's coming galvanometer, that time I'll discuss why I'm stressing this point. Ammeter is a device. Remember, ammeter is a device is used to measure the electric current. Clear? Yes. So now next one is voltmeter. So what is a voltmeter? So here I am considering voltmeter like this, symbol like this. Okay. Now again 4 points. So just now I discussed potential difference. So yes, right? Potential difference, and once again potential difference clear? Yes. Now see here, potential difference. Understood? Potential difference we are talking. Second one is volt, and third one is voltmeter, and the symbol is V. So here potential difference is the physical quantity. What is a physical quantity? Physical quantity is nothing but, so we can take this marker, so we can maintain this, we can measure the weight of this marker, so how much weight it is there, so that's enough. Okay, physical quantity means the quantity which can be measurable, that is called, what is that? Physical quantity. The quantity which can be measurable, that is called physical. So note down these points. So meanwhile I'll discuss remaining points. Just note down these points, children. Yes, I hope you got it. So potential difference is nothing but a physical quantity which can be measurable. So in circuit we can measure the potential difference, right? Yes. Now SI unit of potential difference is volt. SI unit of potential difference is volt. So how we can measure this potential difference? By using voltmeter. By using voltmeter we can measure the potential difference. Symbol you can take, SI unit of potential difference is volt, the symbol is V. Okay, so this is about potential difference. And next one, Gallner meter. We'll discuss about Gallner meter. Gallner meter. So Gallner meter is the G. So it measures the, no, it won't measure, just it will check whether the current is flowing or not, like a tester. So normally electrician will be having a small tester, right? Small like a pen type model. So when it will plug it, automatically it will glow like a small LED. That is like a tester. So here in electrical components, so we are using the Gallner meter to test whether current is flowing in the circuit or not. So it won't measure, but ammeter will measure the electric current. I said no, remember this point we'll talk about later. So that's same thing. Okay, so I hope it is clear to you related to electrical components. And one more point is there, that is wire joining and wire crossing. Wire joining and wire crossing. So this is a wire crossing, and wire joining is this one, wire joining. Understood? Yes. So this is about wire crossing and wire joining. Now we will talk about one more point, that is wire crossing electrical components over. Next one, Ohm's law. Very important, Ohm's law. Okay, so if you talk about this Ohm's law, so we'll be discussing many times. So whenever we talk about, so even problems, even theory type, everything, it's very important. So make sure that you are using this one, Ohm's law. Ohm's law. Okay, Ohm's law is nothing but, so I'll draw the circuit diagram. So make sure that you are, just I will be drawing. So here 4 cells I'm connecting. Okay, like this, and positive terminal, negative terminal, current is flowing. So ammeter is here, and next one, this is the resistor, and here I'm considering the voltmeter. Voltmeter is here, and I'm talking about a switch. Switch is here, I'm taking closed switch. Okay, best, very nice. Now we can take here, so you need to understand, so this is a positive terminal, negative terminal, positive terminal, negative terminal. So first you have to connect one cell, and next one 2 cell, next one 3 cell, likewise you have to connect. That's the reason I'm taking the dotted lines. Okay, so you should not take directly. Understood? Hope you got it. Now Ohm's law. Ohm's law is nothing but at constant temperature, at constant T, the potential difference across the resistor at constant temperature, the potential difference. So this is a resistor I'm taking, this is a resistor, whatever I'm considering, that's a resistor. So here that is nothing but nichrome wire. At constant temperature, the potential difference across the ends of the metallic conductor, across the ends of the, once again, at constant temperature, the potential difference across the ends of the given metallic wire, once again, so at constant temperature, the potential difference across the ends of the given metallic wire is directly proportional to current flowing through it. Okay, current flowing through it. How much our current is flowing through it? So that is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. So clear? Understood? So V is directly proportional to I. V equal to IR. Clear? That is about this statement. And coming to the process, so procedure. So what materials, before that materials required we have to talk. So materials required. So what are the materials required? We will discuss now. Materials required. So first point, we can take nichrome wire, So nichrome wire of 0.5 meter length. So how much length? So nichrome wire 0.5 meter length. And second one we can take battery. So that is nothing but cells. You can take 4 cells. We have to consider 4 cells, each 1.5 volts. Each 1.5 volts we have to consider. Each 1.5 volts. Okay. So 1.5 volts of each. So how many cells we are taking? 4 cells. So each potential difference is 1.5. And the third one we can consider. So voltmeter. Okay. And fourth one is ammeter. And fifth one you can take connecting wires. Switch also it is there. Switch. And sixth one, what is that? Connecting wires. Connecting the wires. Clear? So this required. These points are required. So main take care carefully. So note down all these points. So these are the materials required. Next one, procedure. So what is the procedure? So we have to take this material required. Next one we will talk about procedure. We will talk about procedure. How we will discuss now. We will see. Procedure. Yes. So first you have to take one cell. You have to connect one cell in the circuit. So that is why we are taking dotted lines. Okay. We have to take one cell and connect in the circuit and take the reading of ammeter and voltmeter. Ammeter is current, voltmeter is potential difference. Okay. Next one, two cells. And so connect the two cells in the circuit, take the reading of ammeter and voltmeter. And repeat the process for 3 cells, 4 cells. That's enough. There is no other cell. So you have to repeat the process for 3 cells and 4 cells and take the reading of ammeter and voltmeter. Then you have to draw the tabular form. So what is the tabular form? That is serial number, electric current, ammeter, V by I form. So we know, so V equal to IR, right? So V equal to IR. So we discussed R equal to V by I. R equal to V by I formula. Is that R equal to V by I? Then we can take here you can consider serial number, ammeter reading, voltmeter reading, and V by I form, that is nothing but R value. Yes, so we have to mention in this tabular form. So 1, 2, 3. Like here also, how many cells we have to consider? Number of cells. Okay, number of cells also 1, 2, 3. And according to the reading. So how many cells we have to consider? That also you have to mention. Serial number of cells, current and potential difference, V by I form. Then we can take and draw the graph for it. Okay, so you have to draw the graph. How it will be if you draw the graph? If you draw the graph for this, so it will become straight line. Okay, so if you draw the graph for V by VI value. Okay, slope of VI graph gives, what is that slope of VI graph? Slope of VI graph gives straight line. VI graph gives straight line. Okay, straight line. So if you draw the graph likewise, so So V on y-axis, X on x-axis, current. If you draw this graph, it will become linear straight line. Clear? So slope is nothing but, what is slope? Slope is nothing but, normally we know y2 minus v1, so v1 by i2 minus i1, that is nothing but x2, y2 minus y1 by x2 minus x1. Okay, so if you take like this, we'll get slope of a graph gives linear, that is straight line. So by this we can able to tell potential difference is directly proportional to current. Okay, so the substances which obey Ohm's law, the substances which obey Ohm's law, those are called ohmic substances. The substances which does not obey Ohm's law, those are called non-ohmic substances. The student which follow teacher's words, those are good students. The students which does not follow teacher's words, those are also good students. Later they will become, they will understand, they will write, they will prepare for exams, right? All are good students only. Okay, right. So that's enough. Next, come to the point. So this is about Ohm's law. The next one, factor depends on resistance, we will discuss. Factors depends on resistance. Ohm's law over, completed. Next, factors. Factors depends on resistance. Clear? Now we'll discuss about factors depends on resistance. So what are the factor depends? Normally you take, so leave the gap here, I am taking now. So here we can consider ammeter, next here, so here battery, switch. Here we have to take nichrome wire you can connect. So what are the materials in this gap? In this gap you have to connect. So XY, in XY gap you have to connect. What are things you have to connect? So nichrome wire, normally nichrome wire you take nichrome wire of double length. First initially nichrome wire of double length you can take, and nichrome wire of thickness will be more. Next one, copper wire. This is a copper wire. Okay, so this one you can take copper wire, and this one is a nichrome wire of L length. This is the L length, 2L length, and 2A cross section same length. So this copper wire you have to take L length, but different material. Understood? So once again listen carefully. So nichrome wire length L, and you can take 2L length nichrome wire, and 2 area of the cross section is double of nichrome wire you have to take same length L length, and copper wire also L length, but different material we are considering. So when you connect each time and take the reading, so then you can understand, observe the reading, current reading in the ammeter, then you can understand that is resistance is directly proportional to length, because that's the reason we are taking L length and 2L length, and resistance is inversely proportional to area of the cross section. That's why we are considering initially this is A only, this is the 2A, and so that's why distance is directly proportional to L by A. So R equal to rho into L by A. So rho is the resistivity. So rho, this is rho is the resistivity. I hope it is very clear to you. Okay, so resistance, R is the resistance, this is the resistivity. Okay, rho is the resistivity, R is the resistance. Understood? So now it is very clear. So R is directly proportional to L, R is inversely proportional to area, R equal to rho into L by A. So by this we can conclude, what we can conclude? Resistance is directly proportional to length of the conductor, and resistance is inversely proportional to area of the cross section. So R is directly proportional to length and inversely proportional to area. So R is directly proportional to rho into L by E. That is R equal to rho into L by U. R equal to rho into L by, right? Yes. Now, so rho equal to RA by L. So resistance already we discussed. Now resistivity we will discuss. Resistivity. What is the resistivity? Resistivity is nothing but resistance of a conductor. Resistivity. So resistivity is equal to resistance of a conductor of unit length and unit cross-sectional area. So once again, resistivity is equal to resistance of a conductor of unit length and unit cross-sectional area. So that is nothing but resistivity. So SI unit of resistivity is equal to ohm meter square by meter. So meter get cancelled, then we will get ohm meter. So resistivity equal to ohm meter. SI unit of resistivity is ohm meter. So clear? So I hope it is very clear to you. This is about factor depends on resistance. So resistance also depends on temperature. Resistance depends on temperature, not only length and area, temperature, and also nature of the material. So nature of the material. So here different material, copper and nickel where we consider, no, it also depends on temperature, it also depends on nature of the material. So overall resistance depends on length, area of the cross section, temperature and nature of the material. Okay, so these are the points. What about resistivity? Resistivity does not depend on physical dimension like length and area. It depends on resistivity. Resistivity depends on, so on what factor? Resistivity depends on temperature, and second one is nature of the material. So I hope you got it. So this is about resistivity depends on temperature and nature of the material. Yes, so this is about factor depends on resistance. Clear? Next one, we'll talk about heating effect of electric current. Heating effect of electric current. Heating effect of electric current. So what is the meaning of this one? What is the meaning of this statement? Heating effect of electric current. Normally we know potential difference. What is the potential difference? V equal to W by Q. So I am taking this a conductor. So I am taking the, like heater is there, right? Normally heater, coil you can consider. Okay, so coil will be like this. So we'll get a heat. Okay, coil. So how it will be? Current is passing through this one. The current is nothing but charge is passing through that. We know potential difference equal to work done. So how much work we are doing? So the potential difference across the conductor, and so how much charge is flowing. Okay, so if the same thing, so we are doing the work at a certain time, that is nothing but rate of doing work, that is nothing but power. So VQ by T. So what is the VQ by T? V into Q by T. So Q by T is what? So we know I equal to Q by T. So rate of flow of charge, that is nothing but electric current. So instead of Q by T we can write I. So P equal to VI. So how much energy is we are getting? So P into power into time, then you'll get VI into T. So whatever energy is we are giving to the conductor, that completely converted or dissipated in the form of heat. So H equal to, we know V equal to IR. So if you write in this equation, then you will get IR into I into T, then you will get H equal to I square RT. Okay, so the definition of heating effect of electric current is, so the source of energy completely dissipated entirely in the form of heat. The source of energy completely dissipated entirely in the form of heat. That is nothing but heating effect of electric current. Means whatever the current is passing through the conductor so you can take heating element. So the total energy will be converted in the form, or will be dissipated or converted or changed into the heat. Okay, so that is called heating effect of electric current. So that we are using for electrical oven, electrical cooker, and iron box. These are the examples we can take. So by converting electrical current into heat, that heat we are utilizing for our needs, right? So this is about a heating effect of electric current. I hope it is about you got it. So we know electrical power, that is nothing but P equal to VI. Okay, commercial unit of energy is kilowatt hour. So the last point is, so what is, only one point is there. So we'll discuss that point and we will we'll end this topic. That is a electric current topic. Based on this one, some problems will be there. So we'll do it later. So what is heating effect? Electrical power. So commercial unit of electrical energy is kilowatt hour. Commercial unit is kilowatt hour. Okay, so that's enough. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. 3.6 into 10 power 6 joule. So that's enough for today class. If you like this video, okay, so if you like the content, if you like the explanation, please do like and share and subscribe to Student Brand. So if you want more videos, do comment. So if you have any concerns, any doubts related to topics, so related to physics, so you can comment below. I'll reach to you. So until that, this is Shiva, your Student Brand. This is the Physics Chat, signing off. Thank you.